Let's continue section 3.7 with our next example B. So here we have an example where we come across a hole. So a hole in a rational function is just a single point that would make our function undefined. So we illustrate it with just an open circle. So we have this function f of x is equal to 3x squared plus x minus 4 divided by 2x squared minus 7x plus 5. I took the liberty of factoring it out for you, and I have the work there. So if you like to, you can always pause the video and make sure you're factoring correctly. That's the factoring work. All right, I'm going to go ahead and erase it. So we see that this x minus 1 cancels to make 1. It's gone. So in return, that creates a hole at x minus 1. We see that if we solve for x, we get x equals 1. And what we do from there is we plug in that x equals 1. So we plug in 1, we're left with 3 times 1 plus 4 divided by 2 times 1 minus 5. So in return, we get 7 divided by negative 3. So that's my y-coordinate. So I have a hole at 1 and 7 over negative 3. Okay, let's go ahead and graph it. It's positive 1 and negative 7 over 3. That is about 1, and it goes in it twice. So negative 2 and 1/3. So 1 and negative 2 and 1/3. It's about here. So it's just an open circle. That is your hole. Now, what we're going to do is we're going to go ahead and graph our new function. So you want to do is once you set that up, you want to forget about it and you want to graph your new reduced function, which is f of x is equal to 3x plus 4 divided by 2x minus 5. You want to, once you set that up, disregard it and graph that. So I'm going to erase that. You want to graph this function here. Well, isn't that the function we just graphed? Yeah, right, 3x plus 4 divided by 2x minus 5. We just did that in the last example. So you want to go ahead and graph it again, but this time you want to illustrate or highlight the fact that there's an open circle by just drawing an open circle. Your graph looked like, I think you had a vertical asymptote at 2 over 5, 5 over 2. So that was 2.5, so somewhere right here. And then you had a horizontal asymptote, I think at 1.5 from your last example. And so we saw that your graph looks something like this, right? Now I just want to point out that if you graph this using a graphing calculator or a tool, it does not point out your hole. You won't see that open circle. So keep an eye out for that. Last example, we have x minus 1 divided by x squared minus 7x equals 6. We want to go ahead and follow all of our steps that we have set up from earlier on the video, that first part of the video. So first, we want to find if there's a hole. Well, we don't know. Let's factor our denominator. So if I factor my denominator, I'm left with x minus 1, and in my denominator I have x. Let me do that little trick. Both factors add up, multiply would be negative 6, but add to be negative 1. 3 and 2 work, I make 3 negative. So I have x minus 3 and x plus 2. And no, nothing cancels to make 1. So let's go ahead and find our x-intercepts, our y-intercepts, and our asymptotes. So to find your x-intercept, you set your numerator equal to 0. So I have 0 is equal to x minus 1. you get x is equal to 1. To find your y-intercept, you go ahead and set your x is equal to 0. So you have y is equal to 0 minus 1 divided by 0 squared minus 0 minus 6. In return, we get y is equal to negative 1 divided by negative 6, which is just 1/6. So I have the point 0 and 1/6, and the point 1 comma 0. Let me graph them. 1 comma 0 and 0 and 1/6, so it's just a small number there. Next, I have my asymptotes. To find your vertical asymptote, you set your denominator equal to 0. We're going to have two vertical asymptotes. I have x minus 3 is equal to 0, and x plus 2 is equal to 0. You move the 3 over, I have x equals 3. I move the 2 over, I have x equals negative 2. Let's go ahead and plot my vertical asymptotes. I have one at negative 2, and we draw dotted lines because I know we won't cross them, and at 3. So that's your vertical asymptote at x equals 3, and that's your vertical asymptote at x equals negative 2. Alright, next I want to find my horizontal asymptotes. So we see our exponents and my denominator is of greater degree. So if we look at our rules, that's the third rule, or the first rule. If my numerator is of smaller degree, then my horizontal asymptote is y equals 0. So I have a horizontal asymptote at y equals 0. And whenever we have a horizontal asymptote, we need to test it. We test it by setting our horizontal asymptote, in this case 0, equal to our function. So I have x minus 1 divided by x minus 3, x plus 2. So I multiply both sides by my denominator, x minus 3, x plus 2. That makes 1. On the other side is we multiply it by 0, so that's just 0. So I'm left with 0 is equal to x minus 1. I get x is equal to 1. So this means that yes, we touch or cross our horizontal asymptote when x equals 1. So we have a horizontal asymptote, which we said we do at y equals 0. So a horizontal asymptote at 0. And we learned that we cross it when x equals 1. And that's this point here. I kind of drew a little x so you can keep in mind that you might cross or touch. We don't know what's going on. Okay, now your vertical asymptotes split your graph. We see here that we have this part going on in the middle, and then it's being split by two asymptotes. So I have this part going on the left and this part going on the right. I need to graph something to see what's going on, and I'm using my asymptotes to guide what we will graph. So on the leftmost part, on this part right here only, I need to figure out what's going on. How do we find out? Well, I need to see what's going on. Let's test a point. Let's test a point like x equals negative 3. Let's plug in negative 3 into our function. If we plug in negative 3, f of negative 3, we get negative 3 minus 1 divided by negative 3. You can use your original one or your reduced one, it doesn't matter. I'll use the reduced one. Negative 3 minus 3 times negative 3 plus 2. This gives us negative 4 divided by, well, negative 3 minus 3, that's negative 6. And negative 3 plus 2, that's negative 1. Negative 6 times negative 1 is 6. So this gives me the fraction negative 2 over 3. So at negative 2 over 3, It's just a small number that's close to -1. Now I only have 1 point, but that's enough to tell me what's going on because I know that I cannot cross my horizontal asymptote and I can't cross my vertical asymptote. So with that said, I have a line that's getting closer and closer and closer, or a curve that gets closer and closer to my horizontal asymptote but never crosses. And I have a curve that gets closer and closer to my vertical asymptote but never quite crosses. Let's see what's going on the far right. So let's test a point like, we can test something like 5. Let's see what's going on at 5. Let's go ahead and plug in 5. So if I plug in 5 into our function, f of 5, positive 5, we get 5 minus 1 divided by 5 minus 3 times 5 plus 2. So we get 4 divided by 5 minus 3 is 2, 5 plus 2 is 7, 4 over 14, so 1 over 7. So we have the point 5 and 1 over 7. Let's plot it. 5 and a little bit over. And again, we're going to use the fact that we know it's going to get closer to my asymptotes, but never cross. We can cross the horizontal asymptote, but it only happens at 1 point and we labeled it. Okay, so I know it's going to get closer and closer to my asymptotes, but never touch. So this point is part of my curve that gets closer and closer to my asymptotes, but never touches. There we have it. Now what's going on in the middle? I'm not sure, and we want to find out. So in the middle, which is just this part right here, we can potentially cross our horizontal asymptote, and we need to find out what's going on. So far what we have, I know to the left of it, I have this point, and I have a point that's slightly higher. So I know it's going to go up. But now my question is, will my graph make like a U and look like a parabola? Or can it have a shift in direction and actually start going down? So those are my two options. I need to see what's going on. So let's test a point like 2. If it's above, then I know it's going to be something like a parabola. If it's below, I know it's going to be something like a cubic. And that's what we're left to discover. All right, so let's go ahead and test the number 2. So if we test the number 2 into our function, we're almost out of space. Let me erase our previous work. If I test the number 2 into our function, we're left with f of 2 is equal to, and we have 2 minus 1 divided by 2 squared minus 2 minus 6. I erased my factored version, so I'm using my expanded one, and that's okay. It gives us the same answer. So I have 2 minus 1 is 1. On the bottom, I have 2 squared is 4, minus 2 minus 6. So I'm left with 1 over 4 minus 2 is 2, and 2 minus 6 is -4. So I have -1/4. So it's going to go down since we have a negative. So I answered my question. At that point, I don't touch it, I cross it. So I cross to continue on and go like this. And after your work, if you want to check it, you can always use Desmos. So let's go back to our Desmos. And I have this here for us. Oh man, I erased it. It's okay. That way you can see how we type it. So we're going to go ahead and type our function. And we had x minus 1, And I use parentheses because then I want to push the division button or the slash button if you're using a keyboard. And we have x squared, so we use x, and then you usually do a caret, but we have exponents here. X squared minus x minus 6. And there we have our function. You can zoom in or zoom out, so let's zoom out a bit. Isn't that kind of what we have? Yeah, right. That is our graph. Pretty neat. All right, so that's our function. I know these are a lot of steps, but once you start doing them, it's not so bad. It's just taking a bunch of little small steps that are not too tough and putting them all together. All right, that's it for 3.7. Thanks.